Hello, I'm discussing about contradiction. So, we say that a statement or set of statement is logically consistent when it involves no logical contradiction. So, what is logical contradiction? A logical contradiction is the conjunction of a statement S and its denial is not S. In logic, it is a fundamental law, the law of contradiction. The statement and its denial cannot be both true at the same time. Either explicitly or logically imply a certain statement and its denial. First is an implicity contradiction. Example of this is you can love someone and love someone at the same time. Second, it is implicity contradiction. Example of this is depends on the unstated but well-known principle. If boy married to girl, girl married to boy. Third is also an explicit contradiction. It depends on the unstated meaning of promising, namely whether you promise to do something you hereby accord or moral obligation to do it. In short, such relation that one proposition is a denial of the other, so they cannot be true and cannot be false at the same time.
A and E propositions are contrary. Propositions are contrary when they cannot both be true. For example, all dogs are small is an A proposition. It cannot be true at the same time as the corresponding E proposition. No dogs are small. Secondly, A and E propositions are contrary. Propositions are contrary when they cannot both be true. For example, an A proposition, all giraffes have long necks, cannot be true at the same time as the corresponding E proposition, no giraffes have long necks. Note, however, that corresponding A and E propositions, while contrary, are not contradictory. They can both be false, as with the examples of all planets are gas giants and no planets are gas giants. Nagets mo yun?
Next is subcontrary. All I and O propositions are subcontrary. Propositions are subcontrary when it is impossible for both to be false. For example, some foods are good is an example of I proposition that it is false. And some foods are not good is an example of O proposition that must be true. So, it is impossible for both to be true. And for other examples, some girls are sexy and some girls are not sexy. They can be both true or yes. So again, I and O propositions are subcontrary, but not contrary or contradictory.
Lastly, the subalternation. Subalternation means that there is a relation which exists between two propositions like A and I and E and O that have the same quality but different in quantity. A propositions stand in the subalternation relation with the corresponding I propositions. For example, the A proposition, all plastics are synthetics, implies the truth in the statement that some plastic are synthetic. However, the truth of the O proposition, some cars are not American-made products, does not imply the truth in the E proposition, no cars are American-made products. In short, the A and E proposition implies the truth of the corresponding I and O proposition respectively. However, the truth of a particular proposition does not imply the truth of the corresponding universal proposition, nor does the false implicity of an universal proposition carry downwards to the respective particular propositions.
By looking at the schematic diagram, we could define contrary as a relation that exists between two universal propositions, A and E. They only differ in quality because A is affirmative and E is negative. Now, let's discuss laws of contrariety. Rule number 1. If one statement is true, the other statement is false. Therefore, contrary statements cannot be both true. Rule number 2. If one statement is false, the other one should be doubtful. Doubtful meaning they can either be true or false. Therefore, contrary statements could be both false. Now, let's take an example on a number system. First statement said, all integers are real numbers. Second, all integers are not real numbers. First statement is affirmative. Second is negative because negation occurs after the copula. Therefore, these two statements are contrary to each other. One is true, the second is false. In the first example, we applied the rule number 1. In this example, we will apply the second rule, wherein it states that both statements could be false, or if one statement is false, the other one should be doubtful. Okay, based on the Venn diagram given, we can conclude that quadrilaterals has 3 types: parallelograms, kites, and trapezoids, and each type has their own subgroups. To understand it better, we could write the Venn diagram in this way. Quadrilaterals has 3 types: parallelograms, kites, and trapezoids. Parallelograms are divided into 2, rhombus and rectangle, and both produces a square. And trapezoids produces an isosceles trapezoid. The first statement says, no square is a rectangle. Negation occurs before the subject. Therefore, this is negative or this is false. The second statement said, all rectangles are squares. There is no negation that occurs before the subject or even after the copula. But we cannot assume that it is true because if we base this statement on this diagram given, we could presume or we can conclude that this second statement is doubtful because all rectangles are square as said in the statement, but it is not because a rectangle produces a square. They are not reversible. Therefore, this statement is doubtful and the other one is false. Based on the example, the second rule applies. If one is false, the other is doubtful.